And so we wanted to take that knowledge base and we wanted to extend it out to, logically, the air conditioning market, which is a much bigger market. So our goal there is to actually get into the jet market. We've always been piston market. So we're gonna open that. So, and the other side of that too is STCs for the piston market. It's kind of you don't hear that much anymore. There's not a lot of support for the piston market. Nobody's really taking the time and energy, and it does take a lot of time. It takes a lot of energy. It takes a lot of money to develop an STC for the piston market. But that is our market for the heating system. So as we get started here, I'm a little familiar with the slides. Look at your eyes. Man, I got a lot of looks in the last 10 minutes. All right, so here's the overview. Where it all began, that's basically what we're talking about. So we're very good at making combustion heaters. Combustion heaters actually, other than the aircraft engine, there's no other component on the aircraft that has as many regulations on it as the engines, other than the heating system. So we are very good at working with the FAA, figuring out how to develop a product, how to get it approved, how to get an STC, how to get a PMA, how to get it on the aircraft, and to keep it safe. So we thought, well, it would be easy just to build an air conditioner. That was 2 years ago. So we're still working on it, but the light is definitely at the end of the tunnel. We've actually got the heating system portion of the STC approved. And now the air conditioning portion, we did it in 2 separate STCs because it's propulsion and mechanical systems with the FAA. So you're dealing with 2 different areas of expertise even within the FAA. So that's why we couldn't just use our normal people. So you've seen different people walking through the shop. That's mechanical systems without under propulsion. So, and development of the air conditioner, I mean, believe it or not, the air conditioner is a much simpler design element than the combustion heater design element is. You wouldn't think so, but parts and pieces, it's pretty basic. The whole trick there is getting it to fit in the aircraft. And what we've done is where normally in aviation you've got, it's kind of like a house where it's set up and you've got a window unit air conditioner and you got a whole boiler unit furnace. Aviation, that's pretty much how everything, even stuff they're pumping out new, is set up. Well, in your home, you have one thermostat. You set the thermostat to 65 degrees, and it's either going to kick on your furnace or it's going to kick on your air conditioner. Same in your vehicles now. You turn it on to the auto setting, it's going to kick on your air conditioner, or it's going to kick on your heating system. Well, they haven't really had that for general aviation. But that's what we've come up with here, is a system that you set it and forget it. And that's kind of what we think is really going to be appealing to people, let alone just having air conditioning in a piston aircraft, which a lot of these piston aircraft, a lot of the designs out there, actually the design for the air conditioning is from a 1960s Plymouth. That's where the first air conditioner for aviation came from. They pulled it out of an old Plymouth and stuck it in the King Air. And that's really where the air conditioning for aviation started to grow from that. It was earlier in the 1960s. But, and if you look at the King Air now, you'll actually find where they have a motor driving a compressor. And so you've got about 40 pounds just to compress the coolants. So it's very way back in technology in its advancements. So we brought it up hopefully to the 21st century. There's some newer systems out there, but again, nothing integrates it with the heating system. And the only reason we're able to do that is because we started with the heating systems. You could not take an air conditioner manufacturer really out there right now. They could not really very well integrate it with the heating systems. Some of the newer variants have that. They've actually taken our heater, which is OEM, and they've stuck in a C-Tech air conditioner, and they've worked it out to work both units together. But even that's been a nightmare to figure out to make it work right. Modifications to the aircraft. Right now, you're looking right out there is the bearing. That's our first install, and we've had a lot of excitement over it, but we haven't wanted to push the product until we've got it just nailed down perfectly. Kind of like our heaters, we don't like to release it unless we know it's going to be it's going to meet the expectations that we have for the system. But we have a very nice, very good working system now, and we'll go out and look at it once we're done here. Modifications to the aircraft also are very, very, very small. Any other STC air conditioner you have out there right now, you actually have to move the spinner on the left engine for the bearing. It's shortened by an inch. The cowl sticks out about an inch farther. There's a big bubble on the top that needs to be blasted in. So there's some pretty major modifications to that aircraft. And if you're like me, I have a little problem with symmetrics. I really like things symmetrical. So seeing, if I was sitting in there and you see the one side bumped out about an inch, that would get to me. So that was kind of part of it. Everybody shot. Yeah. You know exactly what I'm talking about. But the whole point of this thing was really to make a system that was going to not be part of the engine, because you blow a valve on an air conditioning compressor or something, you can have some serious problems with your engine also. But we wanted it completely electrical and not dependent on engine operation. That way you get the opportunity to plug the system in, which we have right now. You can just plug it into 110 and you can heat or cool your aircraft if you're waiting for passengers and stuff. That's kind of the first two. How it performs? It performs really good. That's the answer to that question. It's about a 20-degree differential right now. On our test bench, we had a 25-degree differential. That's about as much as you want to get. So really, the effect here is, like in your car, you have a blasting in your face, which we will have with eyelets and different things. But this is more like central air and heating in your house. Heat rises. So you always have your ducting on the floor for heat. Well, cool air, you say, okay, well, cool air falls. It doesn't. Cool air fills the void. And so what we've done is we've integrated it with the heater. So everything's coming through the same ducting. It's usually utilizing all the original controls in the aircraft. So modifications to the airplane are much, much less because of that. So the system goes in much easier. Because of that, also the price is significantly less than other STCs out there as well. The price is comparable with the heater to just the air conditioner you would get before installation right now. So, okay, we're going to take a look here. We've already gone through the worship company. It all began over spaghetti dinner, and if you want me to talk about that more later, I can do that, but that's really all right. Again, C&D, I mean, we're not hopefully making a claim that we can't back up, but we've had a lot of experience in the heating systems and the ducting in these aircraft and the fuel systems and the electrical systems. I mean, it's just been just an amazing amount of data that we've collected over the years. So really, it blended nicely into the air conditioner. We know the loads, we know what it takes to make this system work properly in an aircraft, because we have a history with the environmental system. And we've worked on air conditioning in the past. Again, it's lag behind in progress, just always remember how it works. Okay, so first of all, the heater. We took this opportunity, the heaters, you have an S50 in your aircraft right now. Well, that was the original design, that was pre-1974. In 74, they went to the newer design, the B series heater, that was the latest and greatest. Well, it really wasn't. What they did is they took a large heater that they had, a Janitrol, and they stuck it in the Baron with a larger shroud. And that's really what the Baron newer B series heater came from. That's why the exhaust was pushed back. Where you've got your exhaust right now is perfect. And that's how the S50 was designed, to fit it that way. The B series, they said, well, all I got is this, so let's stick this in the airplane, we've got to move the exhaust back about 10 inches. And they have a real funky S-curve exhaust shroud in there, and it weighs a lot. So what we said on this design is, anytime we're going to do an STC for an aircraft, we're going to take all of the knowledge that we have, just sticking in our heads right now, we're going to take that knowledge, and we're going to, while we're doing this system, we're going to make that heater the best it can be. And that's what we did. So we took all the improvements that we knew would make that heater work better, not being limited to box, cookie cutter heaters that we're sticking in airplanes. We knew the exhaust was better up front, so we moved that. We put all the fancy control switches that we have now, that we've developed. We really made, everything, that advancement that we had, we applied to this application. And our goal is to do that with everything. So like the Twin Bonanza is going to be the same way. The Twin Bonanza, we're going to gut the system, and we're going to build it the way it should have been built in the first place. It's really what it boils down to. So the heater came out of that. The heater also, why the weight is significantly less than any other systems out there, is because you're able to take an air conditioner and a heater, and you're able to use a lot of the same components. Instead of having two dedicated systems, you can use the same blower, you can use a lot of the same electronics, the same controllers. And so we were able to bring the weight down significantly. The heater itself weighs 6 pounds less. That just gives you an idea. The whole system installed in the bearing is only, basically, it would be like throwing a 28-pound overnight bag in your nose. That's the weight difference from what you have right now. So by the time you change the heater out, you take out some weight, you add the air conditioner, you're only adding 28 pounds to the aircraft versus 60 pounds for any other STC out there right now. So there's a pretty big weight difference there. As far as the heater, lighter by 6 pounds. We relocated the exhaust. You probably saw it, but it's up in the nose now where it should be. It's better airflow there. The air is more stable up there. It operates at higher altitudes better in that location. And we've also done some, we've cleaned the aircraft up significantly too. Once we have the recirculating option put in, we can even take out the gills in the front. So it's really streamlining the aircraft as well. There's not as much parasitic drag on it. Stronger blower. This one shows the filter on it right now. We've been playing around with K&N filters. This is an S&B filter actually. So we're filtering the air. It goes through the system. That's good on a bunch of different levels. Usually you fire off a heater, you fire off your system, and you see a bunch of dust coming out of your vents and different things. This is going to keep those systems clean. But it's also going to keep the coils from the evaporator clean, which is plumbed in line with the heater now. So the filter stays. Solid state switches. All of our heating systems, all of this air conditioning, it's all solid state. We have one bimetallic switch in the system now, and that's just an overheat upper limit, last ditch resort kind of safety switch. But everything's solid state. These switches have microprocessors in them. We can tell a lot from what the heater's done in the past just by seeing what the life of that microprocessor has done. All right, so here's the air conditioner. And we'll go out and look at it. This is on the right side of the aircraft. That orange duct right there, the heat hose, that's the heated air output from the heater. Okay, so that's your fresh air coming in, and that's it's a cylindrical coil evaporator. And that's new also. We've got some technology that we've been working with. It's old military technology, but our coils we can actually make in a circle. Right now, any other air conditioner you see, it looks like a cereal box. You know, it's the square, it's got the aluminum fins, and a copper pipe. That's the design they've been using from day one, really. Ours is a solid piece of aluminum that actually has the fins shaved into it. It's 100% efficient. So that's why we're able to use smaller size units to keep the weight down. The coils are smaller because of the efficiency is very high. Here's a picture of our coils. And you can actually see it. It's extruded aluminum. And when it's extruded, it has tunnels already put into it. And then they go in there basically with planes, and they shave the fins right into the aluminum. It's just incredible material. We can make it in all different shapes and sizes. We can coil it and do all kinds of crazy stuff. Receiver dryer. We use a receiver dryer just because it makes for a more efficient system. Any other system you see out there right now just has a dryer in it. The receiver gives this system an opportunity to be able to work just as well on a hot, humid day up in Michigan as it would on a dry, hot, 110-degree day down in Arizona. You'd feel a big difference running a normal air conditioner up here versus down there, or another STC air conditioner. You feel a large difference in what the output is. With this receiver in it, it's able to stabilize no matter what the moisture or whatever content, you know, it deals with the atmospheric changes of the region you're in. And then we also, the expansion valve is not just a fixed orifice expansion valve, it has a capillary tube on it, so it adjusts also. It's a pretty smart air conditioner, which by smart I mean it's just as smart as any window unit out there right now, but it's 10 times as smart as any aircraft air conditioner out there because, again, the technology just hasn't caught up. Outlet plenums, this is out of Seneca. We've played around with some crazy stuff. We even experimented with metal foam, and we'll see what the future brings with that, but that's pretty neat. That's the evaporator coil. You can see how it's wound tight with coil. That fits right in that duct behind the heater. Compressor is an electric compressor with electronic drive. There's other STCs out there right now that are using this compressor, but it's 15,000 BTU air conditioning system. The thing really only is gonna have to, it's very smart. This system will regulate pressure depending on what your output needs are. So normally the compressor's only running at about 65% in a bearing currently. That's about what we've got ours set at to produce without frosting over and different things. So about 65%. It also has a soft start feature. Right now, you know, if you're at home and you turn on your air conditioner and your lights kind of flicker or they dim, there's a big draw. Well, aviation is the same way. You have to be careful. You have to have your engine spooled up at a certain RPM before you flick the thing on a lot of these systems because it's a large draw on the system. This has a soft start feature, which allows it actually starts at 0 and it builds amperage slowly. So there is no initial draw on the aircraft that way. The whole system runs at about 50 amps when it's running at about 100%. So right now we've got it tuned up to about 100% just to show you how low the amp draw is, and you'll actually see how it builds. It's pretty nifty. Any questions? Yeah.
On the exhaust, the installation manual has a cant, for lack of another term, where the cut through the exhaust is not 90 degrees perpendicular to,
Yep.
it's canted in a certain, that's fine, I can see that. And that cant, would it go rearward or forward to accept pressure or to relieve pressure and ensure your front back? But it's canted at like a 20-30. What does that do?
The heaters work, you know, the original equipment, they'd stick the heater in, they'd scarf it, we call it a scarf, so they'd scarf it half, so it would just pull heat out of the can. They wanted to get the exhaust gases out of the can, that was the point of that. What we have found is every installation, every PMA that we've come up with over the years for combustion heaters, we've done flight tests on, which they never really did. But what we found is the reason why the original bearing heater, your bearing heater, you're probably pulling about 2.5 gallons an hour to heat that thing at 50,000 BTU when it's on high. That's a lot of fuel. Well, the reason why you're running it so fast is because all the hot air is escaping out the exhaust so quickly. So the heater's just on constantly. What we've found is you only need about a 1/2 inch of water vacuum pressure or vacuum on the exhaust. Well, a 1/2 inch of vacuum, like on your Twin Bonanza, you've got that 20-30, little 20, I think it's like a 15-degree scarf angle forward. You got about 1 inch of vacuum still on that exhaust. That heater's only burning, to heat your cabin, you're only burning less than a 1/2 gallon an hour.
Right.
That's why, because that heater's much more efficient. You're not sucking all the heat out of the exhaust. And the other side of that too is where you go out there, you put a temperature probe out your exhaust when it's running, you know, in flight. You're pulling out, there's about 1,200 degrees coming out of that exhaust. Just to give you a comparison, with our heater installed, if we did the STC kit replacement on theirs, you know, any of our STCs, the exhaust temperature is only going to be about 600 degrees. And so that tells you the efficiency of what you're losing there. In a typical flight, our heaters probably will cycle 100 to 200 times per hour. That's quite a bit. You know, they're off on, off on, off on. But at the same time, it's burning only 50. You know, it's only maybe a 1/2 gallon of fuel because it heats the can up, it allows the heat to transfer, and it's not sucking all that hot air out the exhaust. So that's why you see, and that's a great question. Actually, I'm surprised we don't get more mechanics calling us saying, I got this heater, but the exhaust is wrong. Because it looks like it would be scooping air a little bit. And you'll actually see on the bearing, it looks like it would scoop air, but it's still it's a negative pressure. Good question. Oh, yeah, line by 25, runs on low voltage. It runs low enough. 50 amp DC is a lot less than 20 amp AC. I guess I'm saying that right. But you're probably, it must be down around 18 amp or 15 amp because we can run it just fine. Like right now, you can run this air conditioner. We just got a cord, the one that says there's a plug right there. That's just 110, and it runs fine. So the low voltage output, when you plug this thing in, the new systems, they'll cut. It'll interrupt the controller. It'll run the temperature at 65 or 68 degrees, and it'll turn the compressor down to 50%, so that you're not pulling 60, 70 amps if it was to run on high amperage. So that's why the low voltage is important, so that we made this thing just plug in. That's where that compressor comes in. That compressor actually, you know, you think 40 amps is a lot of amperage, but it's really not for a The blower pulls 15 amps, not even. You can't even be pulling 15.
12.
And that's a high, so. Located entirely in the nose. The other point of this whole system was we didn't, especially on the Baron, you want to keep all that nice luggage space. We taught, beach talk, we taught guys throwing golf bags in the front, different things like that. So a big part of this was that we didn't want to interrupt any part of the aircraft. And that included the ducting. That's why we tied it into the heating systems, because we didn't want the big bulky overhead ducting through the cabin. And we didn't want to interrupt the fresh air. Those things interrupt the fresh air. So what we've done is we've pulled it over the glare shield. We're going to put eyelets in it, and it circulates through the cabin. Really nice. Here's our controller. The controller is a really smart controller. There's a lot going on in there. You have different settings here. I mean, you put it just on heat, just on cool, but let's say you take it off for Phoenix in January and you're landing here. You put it on auto and set it at, you take your second knob over and turn it, maybe at 12 o'clock, it's 70, 68 degrees. So you're not even going to notice it, but as you're traveling, the heater's going to start off with AC, and as you fly, it's going to turn the heater on. And it's going to keep up the temperature. It's going to start to cycle the heater faster and faster to get up to Michigan. So you put it in auto, you're not even going to worry about it until you're ready to land. It's going to do everything you need it to do.
Where's the thermostat reading that temperature?
There's a thermocouple that is, there's going to be one on the face of the new models, but right now it's a thermocouple that just you put up at the top of your glare shield.
So that sort of measures just
Cabin temp. Yeah. There's a couple other places it's measuring temp. It's measuring temperature at the back of the heater. There's also a thermostat where the old one used to sit on the Baron. Yours would be in the duct behind the heater. So there's a few other thermostats that are working in conjunction with that to make sure it's, every aircraft is going to be a little different. So what we've done is we've put a bunch of thermocouples in there. We've tried to see where the most stable airflow is in the cabin with the flight. So it's not getting drastic air changes. A lot of airplanes you feel get hot and cold, as the heater turns off and on. We wanted it in a nice, stable location. The thing cycles every degree, so that tells you how fast it's kicking out. It's got a troubleshooting guide in it. It's got a whole bunch of menu and select buttons. They'll be able to tell you all what the system's doing, pressures, all kinds of good stuff. And then again, you get the selectable settings. They have nice touch screen displays, that we've seen out there, and we played around with the idea of making just a nice touch screen display. But I have a touch screen display in my truck, and it was we reverted back to the fact that when I'm driving around my truck, which is pretty bouncy, it's very hard for me to do anything on that touch screen display. So we actually went backwards with what we were designing there, and we put tactile knobs back in it because a few different reasons. It's hard to find find that screen when you're bouncing around in an airplane, but also at night, different things when you're flying. You don't want to pay attention to what's on the screen. You want to be able to reach over and just tactily feel where the settings are. So you feel the knob, and if it's at 12 o'clock, I know I need to turn it down a little bit. So that's why we went with tactile knobs. And it's kind of funny because like the G1000, when they first came out with all that Garmin, everything on that thing was touchscreen. I don't even think it had an on button. That's about all the initial ones had. But now if you look at the newer ones that they're coming out, they're actually going back to knobs. They're starting to get more and more knobs back on the side of them again. Because it's again, the touchscreen is kind of difficult in airplanes. Modifications to the aircraft. Pretty well looking at them. It's very minimally invasive on the aircraft. The pitot tube is the most noticeable thing there in the nose. The gills for the air conditioner sit after that, which you can't really see when you want to look. But again, we really cleaned up the installation. So anything that we're going to do, we're going to do with every time I see the 421 or the 340s, and they have those big monstrous gills in the front of the condenser, just a huge drag on the aircraft. It annoys me because I just want to get rid of it. I just gotta get rid of that stuff. So because of the efficiency of the coils, we can do a lot of cleaning up on these airplanes, and that's our goal here. Somebody once talked about how they put hubcap covers on their wheels, and they gave them 2 knots, and they were just so stoked about that. So if they're stoked about hubcap covers, I can't imagine So it's really going to clean up the aircraft really well. Modification wise, again, everything is in the notes. The only thing that you have to upgrade would be your alternators, and possibly some wiring, if the wiring's not capable of handling the inverters. So it needs at least 100 amp alternators. We're doing plain power 150s. This one's got hearts and hundreds, but the 150 plain powers is what we're recommending. And this is kind of what we've been doing. We're going to do these installs in stages because there's quite a bit of time that goes into this. There's some paint work that's got to go into it. A typical heater installation and modification, you're probably going to have maybe 20 hours into that if we're doing it. The AC side of it is going to take about a week to finish everything else off. So that's paint, installation of the air conditioner and the gills and different things like that. So it does take some work to get that in, but it's about a 2-week process for us if we get an aircraft start to finish. That includes paint. All right, now you see this is the exhaust system sitting right down in front of the strut there, pitot tube. If you notice, there's a shroud around the exhaust pipe. It's got an 1.5 inch exhaust pipe. It's got a 2.5 inch shroud around it, and it's got a scarf on it. Well, this is just like we were talking about earlier, Dale, that this forward scarf still has a vacuum on it. But you're out of the static pressure of the aircraft. When your aircraft's flying along, there's about 2-3 inches of just really nice, calm air. But you don't want to have the exhaust up in that area too much because that nice, calm air just pushes the exhaust stain right up on the belly. So we bump our exhausts out a little farther, get them into the stream air, the non-static. And this is actually our combustion air intake now. And so we're heating our combustion air as it goes into the aircraft. When you do that, when you're heating the air as it goes into the heater, you're preheating the air, so the heater's working half as much again because it's heating hot air. And that's been kind of a revelation for us when we thought about it. It's just like, well, why didn't anybody do this 40 years ago? So, and it really works well. It very, it stabilizes the air, heats it up, preheats it. You don't get icing on your combustion air inlet, different things like that. So every new installation, this is the route we're taking. So that's, now you guys see kind of why we did that start. When I did that first on the Cheyenne, one of the it's a dirty word. But yeah, Cheyenne, reheating the Cheyenne is where that all started. And it works so well that every new application we have now we do this. So one hole, and you got the combustion intake and exhaust. Yeah. And you still get about 4 inches, 5 inches of water, ram air through the combustion air side of it with about 1.5 inches vacuum on it. So there's a fine line there. It took a lot of tuning to figure that out, but it works really well. It burns much, much cleaner. There's the condenser coil gills. That's all I said. We'll see that out there. How it performs. Okay, there's a 25-degree differential that we talked about. And the thing will just run all day long. It'll just sit there and just kick out. Nice, a byproduct of having an air conditioner, especially when you recirculate, is you're dehumidifying the air. So that's a nice bonus, especially when you live up here, you live up in the northern areas where you get some higher humidity. It'll defrost the air really well. So, and it does. We'll run that thing out here just for a couple minutes, and you'll just see water just start to drain right out. This is our test setup. This is some of the DO-160 testing that we had to do. Just showing the system all together. It's kind of what it looks like riding the aircraft. That long cylinder with the red ski hose sticking out of it. That's a mock-up of the heater itself. Then you just see all the components and some of our field test gear. Just ran the thing, ran it as much as we could just to make sure that things were